So we were looking at transformations of functions. We looked at the vertical shifts. These are the red ones. So when you have a plus a number outside of the house, you're going to move vertically up, up. When you have a minus a number outside of the house, you're going to move vertically down. And then you have the horizontal shifts, right? The horizontal shifts, and these are the blue ones. We've looked at those. When you have a minus a number inside of the house, you're going to move to the right. The opposite of the sign, right, right. When you have a minus, you move to the right. And when you have a plus a number inside of the house, you're going to move horizontally, but opposite of the signs, you're going to move to the left. So when you have a plus inside of the house, you move to the left. So we looked at those vertical shifts in red, those horizontal shifts in blue. And now we want to do the last bit. Maybe I'll call these purple. So let's say you have a negative out in front of the house. Like in this case, let's say we have y equals negative, and the negative is out in front of the house. Negative f of x. I want to focus on this for a moment. Now here's our x-axis. And here we have the y-axis vertically on the left side. This is the y-axis. And let's say I have a function, I don't know, call it y equals f of x, right? So I pick an arbitrary point here. This is green point. The input is x. The output here on the y-axis is f of x, right? Input is x, the y value is f of x. So let's say I want to come up with a new function. Purple function. Y equals negative f of x. Think about what the input is here. The input is still x, right? But the output this time is negative f of x. So where's negative f of x? Oh, if this is 0 right here is a y value. Negative f of x is going to be down here, right, on the opposite side of the x-axis. So there's negative f of x. We put that together to get a point. We're going to call that our purple point. So that is basically the green point, right, flipped upside down. So if I were to take another green point here, a little bit to the left of the first one, that one would flip upside down too by this logic. That'd be nice if it wrote something like that. If I took another green point up here to the upper right on the green graph, that would flip upside down as well by this logic. So it would be somewhere down over here, right? If you connect the purple dots, you get something like this. Now basically you get a mirror image about the x-axis. We call this a reflection about the x-axis. Yeah, so essentially what happened, so let's actually look at the point back here. If you look at the green point that we started with, right, the input was x, the output was f of x. The point on the other side that got flipped, that's called what? X, comma, negative f of x, right? The output is negative f of x. So essentially what we did, we took the y value here, which was f of x, and multiplied it by negative 1 to get negative f of x. So really we're multiplying all the y values by negative 1, which is reflecting the graph about the x-axis. So looking at our table, we said that when y equals negative f of x, when you have a negative out in front of the house, that the original y coordinate is going to be multiplied by negative 1, and that's going to reflect everything about the x-axis. In a similar way, when you have a negative x inside the house, a negative x inside of the house, instead you're going to multiply the original x coordinate by -1, and you're going to reflect everything about the y-axis. Let's do some examples of these two reflections. Examples. Graph the function using transformations. Okay, number one, I got y equals, let's say negative x squared. Negative x squared. So if we focus on this negative out in front of the house, that's the big difference between the x squared function. You cover that negative up, you can see very clearly that what's left is the parent function y equals x squared, right? That's going to be our parent here. Parent y equals x squared, and by now we should be very familiar with this graph. So there are 5 key points we said you need to be familiar with on this graph, right? There's -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So I want all of those points, those 5 key points, I want them graphed nicely. So what happens when we look at y equals negative x squared? This negative out front, that's out in front of the squaring function, right? So it's out in front of the house, so we're going to reflect the parent about the x-axis. So I'm going to take all my points and flip them upside down. So this point here at -2, 4 is going to flip upside down to -2, -4 here. This point at -1, -1 is going to flip upside down to -1, -1. Oh, so it was at -1, +1, it's going to flip upside down to -1, -1. That's the better way to say it. The correct way to say it. 0, 0 is going to stay. 1, 1 is going to flip to 1, -1. And what? 2, 4 is going to flip over to 2, -4. So you get an upside down parabola. Now let's go ahead and give it its own graph here. All by itself. Final graph. I'm just going to recopy those purple points. -2, -4. -1, -1. 0, 0. 1, -1. And 2, -4. And it's not sharp edges, it's curved. It's like an upside down U, you could say. There it is. It's y equals -x squared. Okay, we're done with that. Now we want to do another example of a reflection. Number 2, let's say we have y equals square root of -x. Now this looks like a lot like the square root function, except inside of the house we have this negative out in front, right? But it's inside of the house, it's not out in front of the house, right? If we're out in front of the house, it would be a minus square root of x, but no, we have a square root of -x. So if we cover up that minus right there, we see you get y equals square root of x would be your parent, right? Your parent. Parent, y equals square root of x. This is one by now that you should be very familiar with. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. All right, so key points for the parent are what? 0, 0, 1, 1, 4, 2, and 9, 3. It does something like that. So basically what we have to do, what do we have to do is the question. What does y equals square root of minus x? What does that look like is the question. Well, notice that the minus is inside of the house, out in front of the x. Inside of the house, but out in front of the x. So you're going to reflect about, this time the y-axis, reflect about the y-axis. So I really didn't give myself enough space here. Negative 1, 2, 3, negative 4, negative 5, negative 6, negative 7, negative 8. Should be a negative 9 over here I need to go to. So basically I have to flip all my green points here to the opposite side. So 0, 0 is going to stay. 1, 1 is going to flip over here to negative 1, 1. 4, 2 is going to flip over here to negative 4, 2. And 9, 3 is going to flip over here to negative 9, 3. And our graph's going to go sweep back this way in the opposite direction. So it reflected about the y-axis. Now let me go ahead and give this graph its own little coordinate plane. A glorious graph all on its own right. 1, 2, 3. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. Right, so remember our key points. Purple there, negative 4, 2, and negative 9, 3. Those were our key points. It's doing something like, well, not great, is it? Let me start at the center and go up. That would probably be better. There we go. There it is. Y equals square root of minus x.